In this experiment, we will be measuring a current voltage curve for a diode. You will have several pieces of electronics equipment, including a DC power supply, a solderless breadboard, and handheld digital multimeters.
This is the DC power supply. It has two independent channels, and it can work in two different modes. You can use voltage limiting mode, in which you set the maximum voltage allowed by your circuit, and then you can vary the current. Or you can work in current limiting mode, where you set the maximum current allowed, and then vary the voltage. Notice that you have two voltage knobs here, one for coarse adjustment, the other for fine adjustment. And you also need to turn on your channel in order to get an output. Finally, note that you can wire up the two channels in series or in parallel should you require more voltage or more current. These are our breadboards. A breadboard is a grid with predefined electrical connections for building temporary circuits. You may find them useful to build your diode circuits.
In the lab, you will see the two breadboard styles here. Though they are slightly different, the underlying layout pattern is the same. Let's look more closely at the blue breadboard.
It is composed of bus strips and terminal strips. The bus strips here, here, and here are all connected horizontally but not vertically. The gap in the middle here indicates that the bus strips on the left are not connected to the bus strips on the right. The terminal strips, on the other hand, here and here, are connected vertically but not horizontally. Again, the gap in the middle indicates that the top terminal strips here and the bottom terminal strips here are not connected. It's common to run power and ground connections through the bus strips and put electrical components in the terminal strips. Now, to make a connection, you just poke a wire in, like so. You only need to put in maybe half a centimeter or at most a centimeter of wire.
Occasionally, you might find that the hole in the breadboard is a little too tight for the wire, in which case you might want to use a pair of pliers to push the wire in.
These are our handheld digital multimeters, or DMMs for short. We have two models in the classroom, one blue and one gray. They operate the same way, though they have slightly different technical specifications. Let's take a closer look at the blue one. Power switch is here, and in the middle is a dial for selecting the measurement mode. Of most interest to you in this lab are probably the resistance measurements, DC voltage measurements, direct current measurements, and finally the diode test. On the bottom here are the terminals where you take your measurements. They all accept the magnetic connector, which is shown here. And then you plug in like so. You want to use these two terminals for voltage, resistance, and diode measurements. You want to use these two terminals for small current measurements, smaller than 200 milliamps. And you want to use these two terminals for large current measurements, larger than 200 milliamps. Now, both of these DMs do have fuses, and if you improperly use the low current measurement terminals, you will blow that fuse. If you find that your low current measurement terminals do not work, then talk to your instructor or the technician to check whether the fuse has been blown. If you have blown a fuse, please check your circuit before using the DMM again.
One additional note, in one repetition of the experiment, you will be cooling the diode with liquid nitrogen, so we need to go over its safe handling. The diode has long wires attached to it so that you can do measurements and position the diode while it is in liquid nitrogen. If you need to move the liquid nitrogen more than a little bit, please borrow safety gloves and glasses to do so. Liquid nitrogen is both a suffocation hazard and a cold hazard. Skin contact with liquid nitrogen or cold objects can cause frostbite. Extreme cold can make objects unexpectedly hard and brittle, so handle cold objects with care. SFU personnel will give you a styrofoam cup of liquid nitrogen and refill it as needed. Please keep the liquid nitrogen in the main lab room where there is good ventilation. While unlikely, you could experience oxygen deprivation. Symptoms of low oxygen include headache, dizziness, nausea, and fatigue. If you feel unwell, don't hesitate to leave the room immediately, warn others, and report the problem.